This will be about exploring the validity of conjectures. So just keeping in mind a conjecture is something that you are assuming to be true given a certain situation. However, if you are able to provide evidence to the contrary of what you're saying, then the validity of your conjecture would be not conclusive. So basically you're looking for counterexamples to what you're saying. So counterexamples to your conjecture. So when we're exploring conjectures and validity of them and trying to seek if there's counterexamples, in these examples we're going to be looking at visuals, so some optical illusions. So in this case, the question on the bottom is saying, are the horizontal lines parallel or do they slope? So as you're looking at them, visually, if you just inspect them, you can see these lines that are in between these black squares and white squares. And it seems, if you just look at them, that, hey, my conjecture could be that these lines are sloped and that there must be some kind of angle in between, and maybe these squares aren't the same size. So you can make all types of different conjectures. But if you're able to find even one example of the opposite of what you've said is true, then you've found a counterexample, and the conjecture is not valid. So here, if I'm going to say that the lines are sloped, then it's up to me to figure out, can I prove the opposite? So the opposite being, if they're not sloped, then they must be flat. So let's try that. Let's see what happens. So I'm just going to use one of the tools here. I'll just pick a ruler. So assuming that it popped up straight across at 180 degrees straight, that this is a nice straight ruler. So we'll just check out the horizontal lines compared to the edge of the ruler. So you can see that this horizontal line is completely on the edge of the ruler. So I have just proven a counterexample showing that that line's straight, therefore it can't be sloped. Is that true for all of these horizontal lines? Well, you could just do the same thing and check them, line it up. And once again, yeah, that lines up right on the edge of the ruler. So this is a straight line. My conjecture that the lines are sloped is invalid. I used two counterexamples to prove that. Let's move to the next one. So this one's saying make a conjecture about the circles in the center. So they're talking about these circles in the middle. Okay, so my conjecture could be that this one's bigger because it looks kind of bigger than the one over here, possibly. Or this one looks smaller. The left circle in the middle looks smaller than the one on the right in the middle. Again, you can make your conjecture and then test it for validity. If it holds true, then your conjecture is good. If you're able to find one example that supports an opposite opinion or conjecture, then you have found a counterexample and your original conjecture is not valid. So let's go with the conjecture that this right circle in the middle is larger than the middle circle on the left. So let's go and use some of the tools in here again, and we'll create a circle. Just put it over top, and then try to match it up a little bit better. Okay, that's not bad. So you can see that the circle is completely enveloped by this black circle. We'll just move it over. And yeah, you can see that it's also completely enveloped. So my conjecture that the right circle was bigger is invalid. I have found a counterexample. Okay, because this is now also within the same dimensions. So I can't say that the right circle is bigger because we just proved that it's not. They're the same size. Let's move to another one. So if we look at this one here, it says count the black dots and see how many there are, basically. Okay, so if we're looking at the black dots, like for me, I might be looking somewhere else that's different than where you're looking. So I'll just put my cursor over here on this dot. Actually, I'm going to look in the top left. So I'm going to start here. I'll put my eyes there and then see out of the corner of my eye, my peripheral vision, where I can see the next black dot. So I see one here. And without looking at that point, I put the cursor there. Then while the cursor is still resting there, I can look at it. Oh, I don't see a black dot anymore. But my original conjecture would have been, I see a black dot right here. So therefore, I would have said the black dot is in the top row, 4 dots to the right. And that could have been just one of many that you could have possibly seen. But by putting the cursor there, I can clearly see that it is not shaded in. It's white. So it's unfilled. So the conjecture that there's a black dot in the 4th position in the top row is invalid. I found a counterexample. It's not filled in. And you can do that from any location on this grid. So this one here says, keep staring at the black dot. So this dot here in the middle. After a while, the gray haze around it will appear to shrink. Okay, so if you do that and you really stare at that middle black dot, you will notice that the surrounding colors start to fade away. So now form a conjecture. Oh, okay, I think that the image must have been made with an ink that fades over time. So it's becoming invisible. So it's disappearing. Okay, to find a counter example to that, to try to disprove the conjecture, to see if it's valid or invalid, you could simply look away, let your eyes readjust, look back, see what's changed. Or you could have taken a picture before and after, or you could have a friend sitting next to you, just looking at the picture and telling you what's actually there without staring at the black dot. Okay, so do any one of those things and then look and see if the gray haze around it is still there. So for me, I've looked away and now I'm going to look back. My conjecture was that the gray haze disappeared. But looking back at it, I can clearly see it's still there. So I've disproven that conjecture because the gray haze is actually still there. And this one here, another popular one that's out there. There's so many of them. So we're just looking at a few of them. This one here is saying, focus on the dot in the center and move your heads backwards and forwards. See what happens. Okay, so your idea is to focus right on that black dot in the middle. And as you move your head closer and further from the screen, then you should see some movement. So my conjecture could be that as I'm moving forward and backwards, the pieces are shifting. So to kind of test this, I'm going to put my cursor on one of the spots. So let's just pick this spot right there. You can do the same while you're moving back and forth. Use this as a reference point while staring at the black dot. So then move forward and backwards towards the dot. You should see out of your peripheral the borders are shifting, but then look back at that cursor and you'll see that it hasn't moved. There's still a piece underneath the cursor. So under here we have, if we would have said a conjecture was that the actual circular shapes are rotating, we would have disproven that conjecture by simply holding our cursor on one of the pieces. So we can see that it's not actually moving. It's just an optical illusion. Which brings us to the next one. So this one here. So if we start, let's say, with this person here. Okay, it looks like he's on a platform. He's within the fence perimeter. So therefore, this must be the top. But then you look at the person he's kind of holding this rope to, and it almost looks like the person holding the rope is holding it downwards to the person on the top of the platform. But how can that be if this person's on the top of the platform? So then you can change your perspective to, what if this guy's just on the other side of the railing, still on the up part of the platform, and he's just holding this string towards this person, or rope, or whatever that is. So that's still kind of possible. So right now, they're both on the up part of the platform. That could be your conjecture. And then from there, that would hold true with these people here. But then you get to this ladder and it kind of blows you away because sure, this guy could be on the top of the platform and consider this the top, but then where is the ladder going and where's the person going that's on the ladder? So then your perspective kind of changes and your conjecture kind of gets blown away by this other visual here. So you've kind of found a different example, almost kind of a counterexample for this one, that how can this be the top if there's someone climbing up further, unless they're just laying on the ground. But that's up to you. You have to form your own conjecture and then try to disprove or prove that. So that was just a few of them. I'm sure if you do a simple Google search about optical illusions and conjectures, you will find many more visuals to test for yourself.